Look, for the last 2 years robot demos have mostly been arms. An arm on a table, picking things up, folding a shirt, and we all nodded and said progress. At the end of July, Google DeepMind announced Gemini Robotics 2, and the framing shifted. This is not a better arm. It is a model that coordinates an entire humanoid body, from the feet to the fingertips, while reasoning about tasks that take minutes and hundreds of decisions. Let's look at what is actually in it. Now, the thing to understand is that this is not one model. It is a family of 3 plus a safety benchmark, and each piece is doing a different job. At the center sits the vision language action model, the part that actually moves the robot. It takes what the robot sees plus an instruction in ordinary language and produces the actions. The headline change here is whole body control, meaning it coordinates movement from the feet all the way to the fingertips rather than treating the robot as an arm bolted to a base. Alongside it runs an embodied reasoning model, a vision language model rather than an action model. This is the part that thinks about the situation, communicates with people, and lets different robot types coordinate on shared workflows. DeepMind also calls this its safest robotics model so far on constraint following and human proximity. Then there is an on-device variant designed to run at the edge. That matters more than it sounds, because a robot that has to round-trip every decision to a data center is a robot that stops working when the network hiccups. Local inference is what makes reaction times and reliability believable outside a demo room. And shipped alongside all of it is a new safety benchmark called Asimov Agentic, which measures whether the reasoning model will refuse unsafe tool calls and ask for human help when it is uncertain. Shipping the evaluation with the capability is a notable choice, and one worth holding labs to. Strip the announcement down and 3 capabilities carry the weight. First, whole body control. Earlier versions focused on upper body manipulation, essentially treating the robot as a very smart arm. Coordinating the legs, torso and hands together is a much harder control problem, because now balance and manipulation constrain each other rather than being solved separately. Second, dexterity. DeepMind describes driving 5-fingered hands with 22 degrees of freedom on tasks like tying a squishy rubbish bag or unscrewing a light bulb. Those examples are chosen carefully because deformable objects and delicate torque are exactly where rigid grippers have always fallen apart. And third, horizon. The model handles tasks lasting several minutes and involving hundreds of decisions, adjusting when an action fails. Recovery is the underrated half of that sentence. Long tasks do not fail because a robot cannot do the steps. They fail because nothing catches the moment a step went wrong. So how does a task actually run through this stack? Follow one instruction end to end. It starts with a person speaking normally. There is no scripted command vocabulary to memorize, which is the whole point of putting a language model at the center of a robot. The instruction arrives as ordinary speech alongside whatever the robot can currently see. Then the embodied reasoning model works out what that request means in this specific room, with these objects and these people nearby. It plans, checks safety constraints, and decides whether it is confident enough to proceed or should ask a human first. Next, the vision language action model turns that plan into motion, coordinating the whole body rather than just an end effector. Balance, reach, and grip get solved together, which is what lets the robot do something like lean, steady itself, and manipulate at the same time. And when a step fails, and steps do fail, the system detects it and adjusts rather than running blindly to the end. Across a task with hundreds of decisions, that recovery loop is the difference between a demo that works once and a robot that works on a Tuesday. Alright, let's lock down what Gemini Robotics 2 actually delivers. This is a family rather than a single model. There is the vision language action model that acts, an embodied reasoning model called ER2 that plans and communicates, and an on-device variant built to run locally at the edge. The headline capability is whole body control. Where earlier versions concentrated on upper body manipulation, this one coordinates a humanoid from feet to fingertips, so balance and manipulation get solved as one problem. Dexterity Move 2, with 5-fingered hands at 22 degrees of freedom handling deformable objects, across tasks lasting several minutes and involving hundreds of decisions with recovery when an action fails. And the reasoning model lets different robot types coordinate on shared workflows, shipping alongside a new safety benchmark called Asimov Agentic. All 3 models are in early access. For more robotics releases taken apart properly, come find us at standarity.com.